Welcome to Scale Up University. Welcome to the course on building applications with AI agents. So, this is the lecture 1 of module 1, and this lecture is why AI agents matter today. So, that is the lecture why AI agents matter today. So, if we try to understand the crux of this lecture, like what exactly we will be discussing in this lecture. So, this lecture talks about the inevitable evolution. Like now we are moving towards the era of agentic AI agents. So this lecture will talk about like why at all we are discussing about AI agents and why now. Why now we are discussing AI agents? Because before building AI agents, we must understand their fundamental existence. Because if you look at the evolution of computation, so early computing is all about like there used to be very large mechanical computers which was used for some mathematical calculations. Then we saw with the evolution of electronics, personal computing came into picture with graphical user interface and internet, and the computation it took a new form, like it was a very big revolution. Then we saw mobile computing, cloud computing. It was more about connectivity. So this was the evolution of computing, computations. And in this trend, now we have AI agents. So that is the next phase of computation, AI agents, wherein we talk about autonomous action and reasoning. Autonomous action and reasoning. So AI agents, they are not a trend, they are not a buzzword, or they are not just LLMs with tools. Like we might consider that okay, large language model along with some tools will make up AI agents. But that is not the scenario. That is what we will uncover in this course. You will get a very good understanding about what exactly is AI agents. What do we mean by autonomous AI agents? They are not LLMs with tools. So in this lecture, we will be exploring like the main focus of this particular lecture will be to discuss the problems the agents will solve, the complexity crisis. Then we will be looking at some of the limitations of previous approaches. Like previous approaches, we used to use static tools. The world where we live in, the environment is very dynamic, but unfortunately, the tools are very static. So that was the limitation of previous approaches. And then we will discuss the environmental shift, wherein now we are talking about real time systems, wherein we are trying to capture unstructured real time data like high velocity, high volume data. And we are trying to integrate like real time systems is all about like getting the input and acting on the environment. So all this we will discuss. So the crux of this lecture is to get an idea that why exactly we are concerned about AI agents, why AI agents matter today, the problem agents solve, the limitations of previous approaches, which will give us a motivation, and the environmental shift, how the world around us is evolving, and why agent is the choice. AI agent fits perfectly in the evolving world. All that we will discuss in this lecture. So if we look at the topics we will cover in this lecture, so we will be starting with the evolution of artificial intelligence systems. Then we will be talking about limitations of traditional software systems. Then why static automation is no longer sufficient. Then we'll discuss rise of complex, dynamic, real-world environments. Then we'll talk about why autonomy is the next leap in artificial intelligence. Then we'll talk about tools versus models versus agents. Then we'll talk about historical shift from rules to reasoning systems. Then we will be discussing industries being transformed by agents. and then we will discuss productivity, decision making, and scale advantages. And finally, we will conclude this lecture by discussing positioning agents in the modern AI ecosystem. So, all these topics we will cover one by one in this lecture itself. So, let us start with the first topic. So, this is the module one. So, the module one is the introduction to agents, and the lecture one, why AI agents matter today. And the first topic of this lecture is evolution of artificial intelligence systems. So, if we look at the evolution of artificial intelligence systems, we have to start from the very beginning. So, the beginning was the phase one, and it was rule based systems. So, the year 1950s to 1990s, like whatever systems we had, we used to call it like expert systems also. They were rule based systems. So, the idea was in those rule based systems, there was explicit if then logic. And the idea was we have to write the logic. Rule based system is we have to feed the loops. Expert systems, we have to feed the loops. Logic, we have to feed the logic. We have to write the logic. And based on that logic, the system will take input and it will generate an output. So it was very deterministic because it was very much understood that, okay, this is the logic. If this is the input, this has to be the output. Deterministic means we can easily predict the output of the system. Given the input, we can predict, okay, if this is the input, this will be the output. So the rule based system, they were deterministic in nature, and they were brittle and non adaptive, meaning to say that if there is some ambiguity in the input, then the system will fail. And system, like, it is pre-programmed because the logic is fed. Now with time, if the concepts are evolving, if the logic is changing, system cannot adapt, because whatever is pre-written logic, system will behave according to that. And hence this system is non-adaptive and it is brittle means if some uncertainty in the real world or in the input, the system will break. It will not be able to adapt. That's the idea. So the example of a rule based system is, let us suppose there is a logic that, okay, if the temperature is greater than 100, then shut down the machine. Now the limitations, as we saw, like the limitations of rule based systems, rules explode combinatorially, because if I am writing all the rules, may explode, because it might keep on increasing. Because if I am making a expert system for a particular healthcare segment, the rules might keep on exploding. Rule based systems cannot handle ambiguity. They cannot handle ambiguity, and they fail outside predefined scenarios. Rule based systems, they fail outside predefined scenarios. Because that's very clear that, okay, whatever logic we have fed, we have written, the system will behave accordingly. If something happens outside that logic, system will fail. So the rule based system will fail outside predefined scenarios. That's the idea. Now the next is the traditional machine learning system, the phase two. Because we are talking about the evolution of artificial intelligence systems, we started with the phase one, that is the rule based systems. Now we are moving towards traditional machine learning systems, that is 1990s to 2015. Now in machine learning, the idea was we used to supply huge amount of data to an algorithm which can learn patterns in that data. So we call it like the training data. So machine learning systems are statistical models trained on data. Statistical models trained on data. So machine learning is based on pattern recognition. Machine learning systems can recognize patterns in the training data, and it is mainly focused on predicting something, either predicting a value or a real number, or predicting any class label, or predicting trends based on the time series data, or predicting weights or the priorities for recommendation systems. So machine learning systems are prediction, like they are basically predicting. They are based on pattern recognition, wherein They recognize patterns from the training data. Now, the capabilities of machine learning systems, they can classify. Classification means whatever input, they will label it. Okay, this input belongs to class A, this input belongs to class B. Regression is predicting a real number. Recommendation means like based on several options, it will pick two, three most suitable options. So it will recommend those things to the user. And forecasting means based on the time series data, we'll be predicting some trends. So all these are the capabilities of machine learning systems. So machine learning systems, the good thing about it is that it is adaptive to a certain extent, because if some ambiguity is there in the input, then also it will be able to handle it, because machine learning can handle uncertainty. Machine learning systems are designed in such a way to handle uncertainty. Some ambiguity in the input, machine learning systems can give us a reasonable output. It can handle those ambiguities. So we can say that machine learning system is adaptive to a certain extent. That's a very big evolution actually, because in machine learning system, the good thing is that no need for you to write the rules. Because see, what is artificial intelligence? Artificial intelligence means algorithm on its own should devise a way to solve a problem. If we tell algorithm how to solve a problem, then it is human intelligence. Then though algorithm will just be a dumb. It will just follow our instructions. How it can be intelligent? For it to be intelligent, we will tell our requirement, okay, we want to achieve this, and algorithm will on its own identify a way or solve a problem to get us the result. That is artificial intelligence. So the rule-based systems, we cannot say to be truly artificially intelligent, because there we have to tell the way of solving a problem. That was a very big drawback. But in machine learning, the good thing is that we don't know how to solve a problem. We just tell machine learning systems, machine learning algorithms that, okay, see, this is the input and this is the output which I want. So for this input, this will be the output. For this input, this will be the output. And we give millions of training data, wherein input output mapping we give. And algorithm will on its own recognize the pattern that, okay, if this is the input, this has to be the output. If this is the input, this has to be the output. It will learn the pattern on its own. We never tell it the way to learn the pattern. So since it is learning the pattern on its own, and when you give it a test input, it will figure out the output on its own based on the pattern recognition which it did. Hence, it is truly an artificially intelligent system. So machine learning is truly artificially intelligent system. Now the limitations of machine learning, see, we already saw that machine learning systems, they predict, but they do not act. Meaning to say that they can do some predictions, but they cannot perform any action. They will just give the output to the user, and user have to take the decision. So machine learning systems, they do not plan. They do not reason across steps. They do not decide what to do next. So they don't have the power to act. So machine learning systems, we can say it to be very passive in nature. They're passive. They cannot plan. They cannot reason. So what is plan? Plan means, okay, I want to achieve an objective or a goal. So step by step, okay, I have to do this, step 1, step 2, step 3, step 4. So plan means to achieve a objective, a goal, I'll figure out some steps of execution. Then every step, the reasoning capability, like, okay, to perform this step, what actions I like, how I can accomplish or how I can execute this step. So reasoning. And what decide what to do next. Okay, this step accomplished, or there was some problem, then what is the alternative way? All that. So this kind of a intelligence is missing in machine learning systems. Okay, now we are discussing the phase 3, Phase 3 was deep learning and foundational models. That is 2016 to 2022, especially the transformer architecture and all that. So deep learning and foundational models. Now what it was, see, deep learning is like neural networks. Deep learning is like a deep neural networks at scale. Now the very good thing about deep learning was, like if we use like a deep neural network, it has a very interesting property of representation learning. Now, what is this representation learning? Representation learning means like whatever natural language we have, the text and all that, we can convert it into a vector space, and there similar words or similar context, they are aligned in a similar manner. So we call it representation learning, wherein uh, text, we convert it into a vector space, we represent it in the form of vectors, and there we learn patterns. And because of this representation learning, deep learning got a special capability, special ability to understand general purpose language like English, French, Spanish, any general purpose language you take, deep learning can understand it, because the language we are converting it into a vector space, and there we are doing the representation and we are learning the patterns out of it. So this made this deep learning very powerful, and it was a very big breakthrough, because now models, they started understanding instructions. Because earlier machine learning, input output, you have to give a input to be a data uh, and output, but now you can give instructions to the deep learning, and AI systems can understand the instructions. So models can understand instructions because of this breakthrough in deep learning and foundation models. Models can generate reasoning like outputs. Now the output of the model will not be just a label or a number or a recommendation or a forecast, but rather it will be a text. It will be more of like a human response. We call it reasoning like outputs. And model can generalize across domains. The idea is that, see, machine learning, the drawback is it is very specific. It is specialized for one task. Like if you train a machine learning model, it is specialized for that particular task. But deep learning and these foundation models, the good thing about that is they have uh, some sort of generalization. They can generalize across domain. It means they have multiple capabilities. It is not like, okay, they can perform only one action. They can perform different set of actions. So that's the breakthrough. Deep learning and foundation models, they can understand instructions, they can generate reasoning like outputs, and they can generalize across domains. Now, what is still missing? Now, definitely, we are seeing the evolution. Okay, so before going to that, let us feel the evolution. So we saw how the artificial intelligence systems, they evolved. We started with rule based systems, which was not at all truly artificially intelligent also, because we had to tell, we had to write the logic to solve a problem. So we are feeding the solution, the way to solve a problem. Then in machine learning, the good thing was we are just giving it an idea about the input and the output, and algorithm on its own is devising the solution. And since it is devising the solution on its own, it is applying its intelligence to solve a problem, because here the problem is solved by the algorithm itself. We are not at all telling how to solve the problem. So that's why machine learning is truly artificially intelligent. But the problem was machine learning was, it was highly specific in nature, and they cannot act, they can just predict. Then we got deep learning. The good thing about deep learning was it became a sort of generalized. It can perform multiple actions, and also it started, it became more intelligent, wherein it started understanding natural languages, it started understanding instructions, and it started generating some reasoning like outputs. So some very good capabilities we got. So here now, uh, the deep learning and the foundation model, and we will call it large language models. So LLMs. The good thing is that they can reason, they can plan. LLMs can plan, they can reason, they can also decide. But LLMs are also, they cannot act. Now the drawback of this deep learning and foundational models, and I am calling it LLMs, large language models. The limitations are persistent goals. The persistent goal is missing. They are stateless. Stateless means, okay, you are giving the input, it will give the output, and it will forget. So it will not. It does not have the capability to stick with the goal. So persistent goals is missing. Memory component is missing. Autonomy is missing. Autonomy means it cannot act on its own. It is dependent on the user. Whatever user will tell, it will just act on it. So autonomy is missing, and execution loops are missing. Like large language models, they cannot execute instructions or execute tasks. That was the missing point. But large language models, they are very smart in that sense that they can plan, they can reason, they can decide what to do next. They can do all this, but they cannot act. And now we are in the phase 4, autonomous agents. And that is what this course is about, autonomous agents. So until now, the AI was very passive. Passive in that sense that, okay, whatever you tell it to do, it will do. Definitely, it will do on its own. You will just tell the AI that, okay, I want this. It will give you the way. Okay, you want this. This is the strategy for that. So it was very passive. But now, autonomous agents, they will go one step ahead. They became active. Now they will not just recommend or tell you the strategy, rather they will execute the strategy on your behalf. So agents, what they can do is that they can decide what to plan, what to do. They can plan actions. They can even make use of tools. So agents, they can on their own autonomy, they can call the tools and perform some data processing, and the result, they can make use of it. They can monitor outcomes, they can adapt over time. So that is the idea, evolution of artificial intelligence systems. So now this is the era wherein there is a complete transformation, and from 2022 we started talking about autonomous agents. So this is a complete transformation. So this is the evolution of artificial intelligence systems. Okay, now we'll look at the next topic of this lecture, that is limitations of traditional software systems. Okay, so see, if we look at the traditional software systems, so traditional software systems, they act like a map. Map means it is very rigid, like the path is there, but it is not adaptive. So the traditional software, it is based on rigid assumptions. It is based on rigid assumptions. It cannot adapt itself to the changing world. So traditional software, it needs stable requirements. But unfortunately, the requirements keep on changing. Like today, the client wants something. Tomorrow, some new idea may pop up, and the requirement might change. So traditional software, it wants stable requirements. It is based on finite states. It wants predictable inputs. If input is ambiguous or something different, the traditional software will not be able to handle it. And explicit logic path means explicit logic path means, in traditional software we have to tell how to solve a problem. We will be solving the problem, we have to code the solution of the problem in the form of logic. So the logic path will be explicit, and that's why traditional software is like dumb in that sense that, okay, we tell each and every step, okay, this is what you have to do now, next, we write everything. So explicit logic path, and it is not at all adaptable. Now the problem is that the real world we live in, the especially the real world data, it is unstructured. And traditional softwares, they are not at all good in managing unstructured data. User intent is ambiguous. So since the user is giving an input, but his intent might be something different. And traditional softwares can never understand the intent. Traditional softwares, they cannot decode the user intent. Systems are interconnected and environments change continuously. The real world we live in, it is continuously evolving, and hence the requirements cannot be stable. And whatever logic we have written, it might need some upgradation. So maintenance is a very big challenge in traditional software. So a traditional script, like a traditional software script, it interpret vague user intent. It cannot interpret vague user intent. It cannot adapt its workflow dynamically, because whatever we have programmed, it will do that only. It cannot adapt itself. If some input is changed, or something, like let us suppose a system wants to communicate with a weather API or some system, if that is not available, then it will stuck. It will just return error. So it is not smart. It cannot recover intelligently from failure. So the because see, traditional software systems we have been using from decades, and we are very much aware about its limitations. And that is where AI agents come into the picture. Now, if you talk about AI agents, now they are not the map, rather they are the compass. The compass means we have a goal, and when we are moving towards the goal, at every point we are like, it's very much adaptable, dynamic. Okay, we want to achieve this goal at every point of time, like wherever we are, we can decide what to do next. Because here we haven't written any program, like we haven't written any logic to solve a problem. The logic to solve a problem is the responsibility of the AI, and hence it is very dynamic in nature. Traditional software, it is very rigid because it will do what we have programmed, and it's very clear that we cannot handle all the scenarios. The real world is so uncertain, how we can expect to handle all the scenarios? But interestingly, AI agents, they can handle all the scenarios, because in the real time, if something unexpected happen, artificial intelligence, it has some idea how to deal with that, because large language model is very smart. If it comes to know that okay, it happened, it will come up with a solution on its own. So it will figure out a way. So that is the very big evolution we are talking about. So AI agents, if we talk about, they are goal oriented navigation, dynamic adaptation, context aware reasoning. Now this is very interesting. The reasoning will be context aware. So the scope of ambiguity is totally eliminated. So context aware reasoning, what it means is, like, based on the current scenario, it will, like, give a generate a response, like what to do next. And continuous learning. So the good thing about AI agents is that it is sensing, the perception is there, wherein it is uh, taking inputs from the outside world, like getting to know that okay, what is happening. Then it will make a plan, it will act, and it will evaluate its action, and then it will re-strategize. So first it will make a strategy, it will execute the strategy, then it will evaluate the outcome, and it will keep on reiterating its strategies. So that's the idea. So we are moving from software as a map, that is the fixed paths, to AI as a compass, goal oriented navigation. So this is the shift in the mindset. And if you want to master agentic AI, it is not about mastering the tools or mastering the coding, it's about mastering the mindset. Now, software development is all about mindset, it's the game of mindset. So, you should have a very good understanding that the mindset will play a role now. So, the shift from fixed path to goal oriented navigation. Okay, now we will look into the next topic of this lecture, why static automation is no longer sufficient. Okay, so first let us understand what do we mean by static automation. So see, in static automation, like the basic idea is that okay, we fetch some data, we process it, and we store the result somewhere, and we might keep on doing it. Like we like some sensor is there, or there is a mechanism through which we are getting some data, we are processing it. Processing means we are applying some logic, and based on that logic, we are performing some set of actions. The results we are getting, we are storing it. So this is a kind of, and why it is static in nature, because the process is static. Because here see, what is the process is the logic which we feed, and that logic is very brittle, like what we feed rigid, that is the logic, and hence it is static in nature. Like whatever input I got, okay, this has to be the logic. And and if there is some uncertainty in the input, if there is some uncertainty in the outside world, some ambiguity in the input, system will fail. It will, because whatever is there in the logic, it can only process that. If something out of the scope comes as input, it will not at all able to process it. It will go away, like it will fail. So that is the static automation. So in static automation, there are fixed workflows. Fixed workflows means human write the logic, like the workflow we make, it is very fixed, predefined steps, no self correction. That is very big thing, because system cannot do the self correction. System will crash on error, it will fail on uncertainty. So there is a need for a system wherein we want dynamic process. So we want, like we don't want static automation, like we want agentic automation. So that is the modern reality. So the modern reality is the agentic automation. And what is this agentic automation? Let us understand agentic automation. Now the beauty of agentic automation is that we can deal with open-ended task. Open-ended task means that the intent might be very vague. Like for example, the task is like, okay, I am planning to do shopping. Now here I haven't specified the exact details, what exactly I want to shop, or what is my budget. And traditional systems can never process inputs such like that. They want crystal clear. Okay, you want to do shopping, exactly what products you want, you have to tell that. And what is your budget, that also you have to tell that. So recommendation will be based on that. But agentic automation, what they will do, they will, because the beauty is that the large language model, okay, I am interested in like I'm planning to do shopping, large language model can understand that general natural language, it can understand, and it can ask follow up questions. Okay, so it will try to decode the intent of the user in a very smart way. Agentic automation can handle dynamic inputs, ambiguous inputs, and also the process is dynamic. That is the main thing, the process, because based on certain inputs, it might come up with a completely different logic, because here the logic is not hard coded, rather AI is solving the problem, because we are just giving the goal to the AI. Okay, I want this. Now AI will figure out how it can achieve that goal. And in agentic automation, dependencies are external. Okay, so agentic automation, they can handle external dependencies as well. The beauty of agentic AI is that let us suppose I want to communicate with some third party APIs, or some third party services for certain task. Agentic automation can handle that. And agentic automation can very easily handle the failures, because it will try a different way. Like okay, it tried to communicate a particular weather API, and it was not available. Then automatically, because large language model is the brain, it knows everything, it will find the alternative option. It will find the alternative option, and then we will go there, we'll try to find that. So that is the idea. So agentic automation is the future. Okay, now we'll look into the next topic of this lecture, that is rise of complex, dynamic, real world environments. So we already got some idea about that. We can just look into it in some detail. Okay, if we talk about modern environments, so they are dynamic in nature because unstructured data, real-time data, and also the conditions they are changing constantly. The modern environment, they are stochastic in nature. Like uncertainty is the normal. Modern environments are interconnected. Like APIs, humans, systems, they are connected with each other, and they are time sensitive. Like real time decisions matter a lot. So modern environments are evolving. Let us look at some examples to make it more clear of modern environments. If I talk about customer support systems, now in customer support, you might encounter a scam user, or you might encounter some problem which you haven't considered. So that is what is we are calling some, like in customer support, dynamic, stochastic, like uncertainty is there. Like we might encounter a problem from a customer which we have never seen before. And this customer support, it has to be interconnected, like multiple screens and headsets and all that, like agents and all that. And it is very time sensitive because we have to resolve or give response in a timely manner, because customer is waiting on the other side. He is waiting for the response, and we cannot like reply him the next day. So it has to be a sort of real time. If we look at other examples like cyber security monitoring, so here also the system might come across new threats which we have never seen before. So that is the dynamic and the stochastic nature of cyber security monitoring. The system might come across some unseen, like never seen before, uh, vulnerabilities or threats. Cyber security monitoring is also, it is interconnected and it's very time sensitive. The response should be very dynamic, real time. Supply chain coordination and research analysis and pipeline. So now it's very clear that modern world is very dynamic. Like I give you idea about supply chain coordination also. So something might happen which have never happened before, or which we have never considered, because we live in a very uncertain world. So the modern world is very stochastic in nature, dynamic in nature. So the idea is that static systems means wherein the logic is already fed, rules are already fed. So that is static systems, they fail, they collapses under complexity, because some sort of uncertainty, the system will collapse, and their agents will come into the picture. Now just imagine if we replace traditional systems with agents, how smart it will become. Any scammer on the other side for customer support, agents can very smartly handle them, all the cross questions, or some never seen before query also, because agent is intelligent, because agent is equipped with large language model, and large language model are very smart. You ask it any relevant query related to any domain, it will give you the appropriate answer. So agents are like very smart. Any cross question, any unseen issue, agent can resolve it to a large extent. In cyber security also, so the idea is that if we talk about dynamic, stochastic, and interconnected and time sensitive modern environment, agents are designed for complexity. They can handle uncertainty, and they are the choice. And that is what is happening now. All the systems like that, static systems, traditional systems, they're getting replaced by agentic systems, agentic AI systems. And that is what is the reality is. Okay, now we look into the next topic of this lecture, why autonomy is the next leap in artificial intelligence. So first let us try to understand what is the meaning of autonomy. So autonomy means now the systems will act on their own. We don't have to give instructions. So acting without step-by-step instructions is autonomy. Choosing actions based on goals is autonomy, like autonomy. And responding to unexpected situations is autonomy. Because now we don't have to feed everything. Now the systems have become smart, they have become intelligent, wherein they can decide on their own what to do. If some uncertain, unexpected situations the system encounters, it will figure out a way. That is artificial intelligence in the true way. Because now the problem is solved or the situation is handled by the algorithm itself or the system itself without human intervention. So, autonomy. So, if we look at some very interesting key insights, so intelligence without autonomy is analysis. So, see, the idea is that if no autonomy is there, then it is just analysis. Intelligence is analysis. And why we are calling it analysis is because what is analysis? And analysis, uh, like we human plays a role, like uh, then the system will use as a tool. System will help humans, but human intelligence will be involved. That is analysis. Like if I analyze something, I'll be using the tools, system as tools, but the algorithm will be designed by me. I will have the recipe to analyze. Like let us suppose I have to do some uh, market analysis. So to do the market analysis, I will be giving the step by step functions. Or if let us suppose I am also not giving, if LLM on its own is doing market analysis, uh, it will not be acting. So here what I am trying to say is that autonomy is also meaning that action, action. So intelligence without action is analysis. Because let us suppose large language model is there, you are telling it to build a state of the art strategy to execute, to achieve something, to achieve a goal. It will do that. So it is more of like a analysis, because it cannot perform any action, it cannot execute it. It is just giving you the strategy or some. So that is an analysis. So intelligence with autonomy becomes agency. So autonomy is where system will act also on the behalf of the user. So intelligence with autonomy becomes agency. Agency means, okay, you just tell it the goal. Okay, this is what I want to achieve. Now it will not just analyze some best practices and give you the result for you to execute. Rather, it will execute on your behalf. That is agency. So now how these agents work, this loop is very important. So first they do the perception, they observe the surrounding, they get the data via sensors, via some user interfaces, via some APIs. They will observe the environment, they will perceive the environment, they will get the data. Then based on the data they received, they will decide what to do. Because for an agent, the goal is always there in the mind. Agent knows that, okay, this is the goal I want to achieve, and this is the input I got. Now it will decide, it will plan. Planning means it will deciding step by step uh, actions to be accomplished to reach the goal. Then it will act, it will execute, it will perform all the steps, actions. Then when it will be doing the execution, it will be analyzing the outcomes, reflect means it will analyze the outcomes of the actions, and based on that it can adapt its strategy. Like it can adapt its plan, like whatever plan it made. Okay, I want to achieve this goal, this is the plan. It starts executing that plan, and it is also reflecting the actions. Okay, reflecting on the outcomes of those actions. Then it will get an idea that, okay, whether I'm in the right direction or I'm in the wrong direction. So it will keep on adapting its plan. It keeps on changing, doing some changes in the plan, so that this is called as alignment. Alignment is the key. Alignment means at every point of time we want our agents to be inclined towards the goal. If the agent drifts away from the goal, then we are gone. So alignment. So this loop, and then it will keep on observing, and this loop will keep on going. So this loop enables AI agents to align with the goal. And this loop did not exist in early AI system. So if you want to understand AI agents, you have to understand this loop. This loop is very important. Okay, now we will be discussing the next topic of this lecture, that is tools versus models versus agents. So if we talk about tools, tools, they can perform specific functions. We know that, okay, we have different tools. Every tool can perform a specific function. They don't have any understanding at all, because tools cannot understand. Now see, tools, whatever program like logic you have written, it will act accordingly, and they don't have any goal, because logic is there. Tool will perform functions based on that logic. Calculator, database query, API. So they are tools. Now, if we talk about models, models, what they can do is they can generate outputs from inputs. Like for a machine learning model, you give it an input, it will predict, it will generate an output. But the or any large language model you take, LLM, like the GPT-4, GPT-5, Gemini, it can understand the natural language and it can provide you a response, but it does not have memory. Like it will not remember the previous responses, and it cannot act, no action loop, like language model, vision model. Now if we talk about agents, agents, the good thing about agents is that they make use of models, they make use of tools as well as, and they work on a goal. So for tools and models there are no goals, but for agent there is a goal. They maintains goal, they are aligned with the goal. Agents can plan, they can decide actions to be performed, and agents are like more of like they're real time, they're operating continuously, the loop which we discussed. So that is agent. So what agent is, agent perceive the environment, it gathers the data, then it plan, okay, what to do, like how to accomplish the goal, then it performs the action, it act, then it reflect, and then it adapt its plan, then once again it will look at the environment. So this loop will keep on running. So, and in this process, like let us suppose the agent, it did the perception, it got the input. Now for planning, it will make use of large language model. It will make use of large language model, that okay, this is the input I have received and this is the goal I want to accomplish. Then large language model will give it a plan. For executing the plan, it will make use of tools, and like that it will keep on doing. So that's the main crux of this. So autonomous agents with tools and models. So the simple rule is that a model answers, or a model gives you a recipe. Okay, model will answer, it will give you a recipe that okay, these are the things you should do. But agent, agent not only answers, but it decides and acts. And agent not give the recipe, but it cooks the meal for you. It performs the actions for you. That's a very big difference actually. So agents, they can act, they will make an action plan and they will act on it. Okay, now we'll look into the next topic of this lecture, that is a historical shift from rules to reasoning systems. So see, we already saw that the evolution of artificial intelligence, we started with rule-based systems, and the problem was explicit logic. We had to give explicit logic. Then we saw the emergence of machine learning systems. The capability was pattern recognition. Machine learning systems, we saw that they can recognize the patterns based on input and output data labels, and they can do the pattern recognition. Then we saw the deep learning, like the deep neural nets, foundation models, the large language models. Large language models, they had the capability of understanding natural language and generating human like response, the generative AI. Then we have agents. Now the beauty of agents is that they can decide, like they can plan and they can act. Decision plus action, that is a sort of autonomy is there in agents, that is missing in LLMs. So this is the evolution. So from rules to reasoning systems, and hence there is a shift towards human work. Now with agents, we don't execute instructions. Rather, we reason, adapt, and decide. Like the systems. Here we means the systems. See, earlier rule-based systems, na, we used to give it the logic, explicit logic. Okay, this problem we have to solve. This is the recipe for that. It just follow that. So earlier system, it just used to execute the instructions. But now the current systems, the evolution we are talking about, they are not executing instructions. Rather, they are deciding how to solve a problem. They are reasoning. The modern AI systems, especially the agents, they reason, they adapt, and they decide what to do. So here the recipe is invented by the system itself. We not at all tell how to solve the problem. The solution is derived by the system itself, and that is artificial intelligence. So agents, they bring computation closer to human like problem solving. So now agents are solving problems like humans do, and that is like a very big shift. It's a historical shift, you can say that. And we are living in a very magical era. Just imagine the evolution, and we should make best use of this. We all should master agentic AI and build some very cool applications. Okay, now we look at the next topic of this lecture, that is industries being transformed by agents. So definitely now we have already seen that like the traditional software systems will be replaced by agents. So if we talk about customer support, so with the power of agents, autonomous resolution will be possible, because without human intervention, we will be able to resolve the queries of the customer to a very large extent. Autonomous resolution, escalation decisions will be taken care by the agents itself. When agents feel like okay, it is not able to resolve the query, it will escalate it to the human. So that will be done by the agent itself. That's a very big thing. The load, like 30 to 40% of the load, the queries can be managed by the agents itself. And sentiment aware response, so the response will be very emotional. It will have a touch of sentiment in it. Like if agent knows that it is talking to a male or female, it will on the fly try to understand the mood of the user. Based on that, the responses can be. So these are like very some big things. If we talk about software development, in software development, agents, they can generate code, they can test the code on their own, they can debug, and they can deploy workflows. Like the software development life cycle, agents can take care of that. Okay, because you just give it the requirement. Okay, this is the requirements I have as a client. It will on its own make a plan. It will generate all the code. It will do all the testing on its own. Different agents will be there for different tasks. Debugging it will do, and it will also deploy the project. So that is that kind of a like uh, accomplishment we can achieve with agents. In healthcare also, if we talk about agents, they can take care of the scheduling without human intervention. Whatever forms are being filled, agents will schedule on their own. Coordination, let us suppose an appointment is scheduled, so agents will on their own coordinate with the patient that okay, and it will be like very dynamic in nature. That's the beauty. See, traditional systems can also coordinate, but it is very rigid. Any uncertainty, it's gone. But agents can handle uncertainty. It can do monitoring. It can also play a role in decision support. Legal and compliance. Like agents can do document analysis. It can do regulatory tracking. It can do the case preparation. Research and knowledge work. Agents can do the literature review, which is a very big thing. It can do the hypothesis testing, and it can do the data synthesis. So agents are like agents will transform everything. This is like a very limited scope we have discussed. Anything you imagine, agents can replace traditional systems. So that is the thing. Like you just look at now, like earlier all the softwares were powered by C programming way back in 1980s and all that. Then advanced technologies, it replaced everything. Similarly, now traditional systems will become outdated and everything will be replaced by agents. Agents is the future, and and it's not the future also, it's the present and the future. We are living in the agentic AI era. Okay, now we'll look into the next topic of this lecture, that is productivity, decision making, and scale advantages. So if we talk about productivity, so see, this is very important actually. If we talk about agents, agents are like very productive. Why agents are productive? Because agents can work continuously, because they are like artificial entities. So they are like software only, na? They can work continuously, no fatigue, they will never get tired. And like 100 like 1000 task or first task, they will execute with the same energy, because humans, see, in the morning they will be very fresh, but by the end of the day they will just get burn out. But for agents it is not like that. Agents can keep on working continuously and they will never get tired, no fatigue. They will perform all the tasks with equal energy, like the similar energy, and parallel execution. And definitely it will maximize the output. It's a very big thing we are discussing. So agents are like next level productivity we can achieve with agents. Decision quality will be next level, because the reasoning will be context aware, which will be a very big thing. Agents have access to vast information, and hence the decision will be not biased. Rather, it will take many factors into consideration. And the good thing about agents is that the reflect means whatever actions is been performed, it will constantly, consistently, it will evaluate. So consistent evaluation is a very big thing. Like, okay, agents made a plan, it made a decision that okay, I will perform this action, and it performed that action, and based on the outcome it will evaluate whether its decision was correct or not, and it will adapt, it will re-strategize, it will do some updations in the plan to achieve the end goal. And that is the beauty of agents. So agents, they optimize outcomes. And if we talk about scale, so we are not limited to only one agents. One agent can interact with many agents, and once again that one agent out of many agent can interact with many agents. So we can just build an army of agents, and we can keep on scaling. So with agents we can achieve distributed intelligence and exponential leverage. So we are amplifying the impact. So that is the big thing we are talking about, agentic AI. So agents, they maximize output, like in terms of productivity, decision quality, scale. They can maximize output, they can optimize outcomes, and amplify impact. So this is like the main crux of this lecture, or the, you can call like the features or the core capabilities of AI agents. So the good thing is that agents multiply human capability rather than replace it. See, no matter what, humans will be needed, because humans will design this flow, the framework. How to make use of agents will be decided by humans. So agents will just multiply human capability rather than replace it. So the future is of collaborative intelligence. Okay, now we will look into the next topic of this lecture, and this is the last topic: positioning agents in the modern AI ecosystem. So in the modern AI stack, what's the role of agents? Agents plays the role of orchestration and decision. So see, the idea is that on the very bottom is the infrastructure. Infrastructure is like the computing capabilities, the GPUs and all that. No, GPUs and all that. That's the infrastructure, the cloud infrastructure. Now, on top of infrastructure, we have foundation models. The foundation models are like, you can call it like the LLMs, plus certain other models as well. Some specialized machine learning models or vision models. Then we have tools and APIs wrapped on top of foundation models. And on top of it, we have agents. Now, agents, they play the three roles. They can or they play the role of orchestration. So there is an orchestration layer. Orchestration means they manage, they orchestrate the these three layers. Because see, the idea is that agents will communicate, interact with the large language model, and based on that, some tools and APIs they will hit, and infrastructure will be used. So orchestration. Agents. So we will be orchestrating these three layers using agents only. Agents acts like the decision layer. So all the decisions will be taken care by agents. So agents will orchestrate. Agents will decide. Decide means they will make the plan and they will act on it. They will reflect. They will adapt, and execution will be done by the agent. So this is very important. So in agentic framework, three important layers are there. Orchestration layer is there, wherein some agents will be involved, responsible for orchestration. Decision layer will be there, and execution layer will be there. It might also happen that a single agent can perform all these three things. That is very, very much possible. So all that we will discuss in this course itself. Let us not get very much confused. So a single agent can do the orchestration, he can decide, and he can execute. Or we can have different agents for different tasks. Like for orchestration, we can have a different agent, for decision, different agent, and these agents can communicate with each other. That is like more of multi-agent. So the idea is that we can say that this agentic framework, and before that, and humans interact with the agent. So humans interact and oversight the agent. So this is the stack, modern AI stack. So agents play a very important role because humans they interact and oversight with agents. That's it. And uh, below that, like agents are now taking care of the bottom layers of the modern AI stack. So we can say that uh, agents are the bridge between intelligence to actions, because earlier it was just intelligence. Now because of agents we can convert that intelligence into action. So agents are the bridge between intelligence to action. So finally we completed this lecture. So this lecture gave us an idea that okay, the real world, the world around us, it is becoming very dynamic. The modern world, the modern environment, it is becoming very dynamic and it's becoming very complex. And unfortunately, traditional software systems cannot handle that sort of complexity. And hence, AI agents is the solution, and that is the reality. Now, AI agents, they exist because they can handle the uncertainty, they can adapt with the evolving modern world. So, agents are not optional, they are inevitable. Like we cannot imagine a modern world without agents, because agents truly add some very interesting value. So I hope you got a very good understanding of the concepts in this lecture. So do subscribe to our YouTube channel, Scale Up University, for more such interesting lectures. Thanks for watching. Thanks for your time.